All right, today we're going to talk about perpendicular and angle bisectors because these things exist in triangles and they give us a lot of powers of things we can do with the information. So let's start by recalling that a perpendicular bisector of a line segment is a line that is perpendicular to the segment at its midpoint. Let us also recall that a point is equidistant from two figures when the point is the same distance from each figure. So in our diagram here, line CP is the perpendicular bisector of segment AB. And we know this because we have the congruent symbol, so AP equals AB, or PB, and it's perpendicular because it's at a right angle. Why is this important? Well, the perpendicular bisector theorem tells us why it's important. Because if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So whatever point we have on line CP, we know is going to be congruent. Distance is going to be the same, A to C, B to C. A to D, B to D, A to E, B to E, or A to F, B to F. So what that looks like in math speak is if line CP is the perpendicular bisector of segment AB, then CA equals CB. Those segments are congruent. The converse is also true. If a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So talking about it in relation to our figure, so if dA equals dB, which is this right here, then point D lies on the perpendicular bisector of AB, and we all remember that this means perpendicular. So let's look at an example to give us an idea of what we're dealing with. So is there enough information in this diagram here to conclude that point N lies on the perpendicular bisector of KM? Take a second, look at it. and answer yes or no. The answer is no. There is not enough information. Because even though we have point L is a midpoint, we need to know that it's a perpendicular bisector, not just a bisector. So we would need to know that the measure of angle L and M equals 90 degrees, or that Kn equals Mn, because one we could use the perpendicular bisector theorem, the other one we could use the converse of the perpendicular bisector theorem. We know neither of those things, so the answer is no, we cannot. Let's look at some more examples. So find RS. This is RS. Here we know we have that Q is the midpoint, that SQ is perpendicular to RP, so therefore it is a perpendicular bisector. So RS has to be the same as PS, or 6.8 units. Go to another example. EG. Well, we know that EH and GH are the same distance from the endpoints, which means that EF and FG are going to be congruent, so both 9.5, and EG, this entire thing here, so 9.5 plus 9.5 equals 19 units. Let's look at another one. Find AD. Right here, what do we know? We know that point B is a midpoint. We know that BD is perpendicular to CA. So by the perpendicular bisector theorem, we know CD is congruent to DA. So 3x plus 14 equals 5x. Subtract 3x from both sides, and we get 2x equals 14. Divide by 2. So AD equals 5 times 7, which is 35. A lot of setting things equal. A couple more. CD. CD is right here. D is a point on the perpendicular bisector, so AD is going to equal CD. So CD is 27. PR. PR is here. We have part of PR, but we know SP and SR are the same. SQ is perpendicular. So PQ is going to equal QR. So PR, which is the whole thing, is going to be 5 plus 5, or 10. Last example for perpendicular bisectors. We know that F's a midpoint. HF is perpendicular, so it's a perpendicular bisector. GH is right here. Since h is on the perpendicular bisector, 3x minus 8 equals 2x. Subtract 2x from both sides, add 8 to both sides, x equals 8. And then we go ahead and plug it in. And GH equals 16. And in the next one, we'll talk about angle bisectors.